Hello everyone and welcome back to my channel. Today we are going to finish our EIGRP authentication configuration with this video, which is the second part. In the first part we configured the basic authentication for EIGRP with a single key with MD5 hashing algorithm. Today we are going to make it a little bit more complex and implement key rotation for EIGRP authentication in a way that, based on the time that we command the routers, the keys will be migrated with or without a time gap between them. Okay, so let's jump right into the configuration part. Before that, we are going to check what we have already. So on router 1, if I do show IP EIGRP neighbor, I would like to check that I have my own EIGRP from the previous video in place. So if I do show IP route EIGRP, I can see that I can see the loopback interface, loopback subnet behind router 2. That's a good news. And if I do show keychain, I can see the first key from the key R1 chain, the only key chain that we made from previous video, is still valid. So for now we just want to get rid of this chain keychain, sorry. So no keychain R1 chain. Our neighborhood should come down now. Our neighbor relationship should come down. Yes, it went down, as you know. And I will jump into router 2 as well. Here I will also do, if I do show keychain, enable password, show keychain, and I can see that my R2 chain, so conf no key chain R2 chain. Okay, so what is the reason that I got rid of that? Because I have created my own configuration template, as you can see in my text editor, Sublime text editor, and we are going to review what exactly it's going to do to my routers, and then we will implement it and we will see the impact in a couple of seconds. Okay, so on router 1, I'm going to create a keychain called R1 chain. It will include two keys, key 1, key 2. And this is the password for key 1, this is the password for key 2. And this is identical with my router 2 keychain, right? On key 1 and key 2, because that has this is important to understand, that the password for key 1 has to match with the password of key 2. Okay? So it's not going to work like if the password of key 1 matches with the password of key 2. Our experience shows that that's not the way that EIGRP authentication works. Okay, but the fun part and the interesting part is in the accept lifetime and send lifetime options. So here on key 1, I am educating my router to say that accepting lifetime at 8 o'clock at night, 7th of May. It means that any packet with for EIGRP authentication comes with this key, you can accept it from this time zone, from this time range. This is the start time and this is the end time. So you will accept it only for 1 minute. Then at the same time you will send this key on the same overlapping range. Okay, this is kind of a best practice because it's a bidirectional communication for EIGRP authentication, and we expect to have the same key at the same time, right? And on key 2, I'm going to tell my router that swap your key exactly at 8 o'clock and 8.2. It means that it's going to wait 1 minute, right? This ends at 8:1, right? It's going to wait 1 minute, and after that, keep it for 2 minutes, right? At the same time for send lifetime as well. So you might notice here that there is 1 minute gap between migrating from key 1 to key 2, and I did it purposefully this way in order to show you that if you are not careful with your configuration in production environment, you might end up with EIGRP neighbor relationship failure. And that's what we are going to see in a couple of minutes. I have the same configuration, just with the different keychain name for R2. So just let's copy that on my key 1, my router 1 and router 2. Okay. This is my router 2. I will conf and yeah. Okay. And also for router 2, if I come here, conf, this is for my router 2. Okay, now if I go to my router 1 and if I do show keychain, I can see that none of them is active. Why? Because if I do show clock, I can see that it's already 9th of May. And this key was active 7th of May, so it's not going to be activated. So I want to, for just only for the purpose of this lab, I want to trick my routers to accept these keys, and by adjusting the clock of my routers to 30 seconds before starting this key exchange and these authentications, and we will wait for 30 seconds and we will see the impact. So I have a code here. Clock set 9:59, 37 of May 2008. So I will just copy this and yes, here and here. Router 1 on router 2. So let's check our clock now. Show clock. Yes, it's correct. Show clock. Good. Now if I do show keychain, it hasn't started yet. In order to see what's going to happen, I'm gonna deactivate debug EIGRP packet just to show you closely the impact of what is going to, and this is exactly when our EIGRP authentication went into effect. As you can see, my neighbor relationship went up. If I do show clock, it's just 20 seconds after that. I mean, we already missed some time, but as you can see here, the neighbor relationship is established, and what I see here is that received packet with MD5 authentication key ID 1. This is the most important part. Key ID 1. So it means that inside my keychain, the key ID 1 is negotiated and accepted on the both sides, right? So if I do show keychain now, as you can see, my key 1 is valid, right? It's valid now. And after 1 minute, as you can see, neighbor is down because authentication failure. And on my debug output, I can see missing authentication. It means that the packet which is coming to router 2, it was supposed to have the authentication field with the right elements, and it doesn't. And that's why I see missing authentication. So if I do show keychain again, I am exactly at the gap of between the two key exchange. So it's 1 minute and 36 seconds and it's still missing authentication, right? So it will exactly start from minute 2. Let's see if we have like 7 seconds, 5 seconds, 4 seconds, 3 seconds, 2, 1, and it should come up right now. Okay, the first one is invalid, and then boom. Exactly at that time, after 1 minute gap between migrating the two keys, I can see that my relationship came up. So if I do show IP EIGRP neighbor, my neighbor is up. Show IP route EIGRP, I can see that the route is received, and look at that. Look at here. If I do on debug all, just in order to stop the debug for you, So EIGRP received packet with MD5 authentication key ID 2. That's beautiful, isn't it? So right now, my two routers are authenticating the EIGRP routing protocol on key ID 2, which means my key 2. So if I do show keychain, I should see that my key 2 is valid, and there you go. It's valid for now. So after that, you can add as many as key you want based on the time spent you want, but you just have to be careful and understand that in production, if you're really willing to implement such a solution, you have to be careful with the timing. The best practice would be if you make like a couple of minutes overlap, then your keys can exchange safely. I hope this video was informative for you, and thank you very much for watching.